Hello everyone, Miss Katongo here. This is another physics related problem. But before we get to the problem that has been displayed on the screen, don't forget to like and subscribe to my YouTube channel. Let's get to it. A taut clothesline has length L and a mass M. A transverse pulse is produced by plucking one end of the clothesline. If the pulse makes n round trips along the clothesline in t seconds, find the expressions for the speed of the pulse in terms of n, l, and t, and the tension F in the clothesline in terms of the same variables and mass m. So, determining the speed of the pulse v, it will be given by the displacement x over the time t. Now, we are told that this pulse is produced by plucking one end of a clothesline. A pulse is basically a wave that is being produced by a sudden disturbance for a short period of time, and it is formed on a small portion of the medium. Let's take for an example where we have two walls, and on one end of the wall we have a clothesline being attached from end to end. So we'll say this point as point A and that point as point B. Remember, a pulse is a single event and it is non-periodic. Hence, we do not expect a back and forth movement of this basic pulse, but rather it will only occur as a single event. Imagine we pluck an end of the clothesline, let's say at point A, and there's a disturbance which is being formed. There will be a wave that will be produced, which will be heading from point A to point B. And once this pulse reaches point B, it will reflect back to point A. The pulse, therefore, will travel the first distance, which is from point A to point B, and the second distance, which is from point B to point A. So hence the distance traveled by the pulse D in terms of L will be twice the length. Now, provided that it makes n rounds, we have to cater for the n rounds. So therefore, we'll have the displacement x being equal to 2L, which is the length of the clothesline, times the number of rounds. Therefore, we'll have our displacement x being equal to 2NL. Replacing this into our equation, we'll have the speed of the pulse being equal to 2NL over T. Getting to part B of the question, where we have to determine the tension F in terms of the same variables, which means in terms of N, L, T, and in terms of the mass, we will have tension in the clothesline will practically be formed due to the speed of this very pulse being produced. So therefore, the speed V in terms of tension or in a string is given by the root of F being the tension over the mu, where we can say mu is equal to the mass per unit length, where we can say the m being the mass and the L being the length, and the tension F will practically be the same. Okay, so determining the speed v is equal to the root of f. Substituting for mu, we'll have FL over the mass. Okay? And then, making tension a subject of formula, we'll square both ends of the equation. We'll have V squared is equal to FL over our M. Hence, we'll have V squared M is equal to F times the L. Okay. Dividing both sides by half of L, we'll have, by the inverse of L, we'll have V squared M over L being equal to the F, which is the tension. Now, previously we obtained the speed of the pulse, which is V, being equal to 2NL over T. Hence, replacing this into the equation, we'll have F, the tension, being equal to 2NL over T squared multiplied by the mass, okay, times 1 over L. Expanding our equation, we'll have 4N squared L squared over the T squared multiplied by the mass times the L, times 1 over L. Cancelling both L's, we'll have 4N squared, the M L over the T squared. Okay. Simplifying our equation, we'll have 2NL over T multiplied by 2NM over T. Hence, we have expressed the tension, which is F, in terms of N, in terms of L, in terms of T, and finally in terms of the variable M.